You know all that amazing AI you use every day? Well, almost every piece of it has a secret engine running under the hood. It's what lets AI see, write, and learn. So today, we're going to pop the hood and take a look at that engine, the neural network.
I mean, think about it. When you ask something like ChatGPT to write an email or generate some code, that incredible, almost magical ability, that's a neural network. Or how about the phone in your pocket? That split second where it just knows it's you and unlocks instantly? Yep, that's another neural network doing its thing.
And what about Netflix? You finish a binge watch, and boom, the perfect next show is right there. That's not magic. It's another one of these incredible pieces of tech.
So what's the deal? What's the common thread tying all this stuff together? What is the secret brain that lets machines do these things that seem so, well, so human? Well, that's exactly what we're about to find out. Okay, so to really get why neural networks are such a big deal, we've got to look back at what came before and, well, why it just couldn't keep up.
See, traditional computer programs, they're amazing if you give them strict logical rules to follow. But the second you throw messy, real-world stuff at them, like trying to identify a face in a crowd, they just fall apart. And that's where neural networks come in. They are built for chaos. They thrive on finding hidden patterns in all that unstructured data that makes up our actual world. So what is a neural network really? At its heart, the idea is actually brilliantly simple. It's a computer system that's modeled on our own brains. Instead of billions of biological neurons, it's got thousands or even millions of artificial nodes, all connected, all firing off signals to each other.
All right, so how does one of these artificial brains actually, think or make a prediction? Let's take a super simple tour. It's probably more straightforward than you're imagining.
So any basic neural network is built with three main parts. First up, you've got the input layer. This is where the raw data goes in, like all the individual pixels of a photo. From there, it flows into the hidden layers. Now this is where the real thinking happens, where all the patterns get sorted out. The more of these layers, the deeper the network gets. And finally, everything comes out the other end at the output layer. This is what gives you the final answer. This whole process, this one-way street from input to output, has a name: forward propagation. The data goes in, it gets crunched through the layers, and out comes a prediction. Simple as that. Is it a cat? Is it a dog? That's the guess. Okay, but what happens when it gets the guess wrong? Because this right here is the most important part. Making a guess is easy. The real genius is in learning from your mistakes. I love this analogy. The best way to think about it is like a giant game of hot or cold, happening millions of times a second. The network makes a guess, and it gets told if it's hotter or colder, closer to the right answer. And then it adjusts millions of tiny little knobs inside itself to try and get a warmer guess next time. So that whole hot or cold game, the technical term for it is backpropagation. After it makes a guess, the network measures how wrong it was. Then it works backward to figure out which of its little internal knobs were the most responsible for the screw-up. It tweaks them just a tiny, tiny bit and then does the whole thing over again, millions of times, each time getting just a little bit smarter.
All right, so here's the thing. You wouldn't use a hammer for every single job, right? Same deal with neural networks. It's not one size fits all. There's a whole zoo of different types, each one specialized for a different kind of task. So let's connect the dots back to those examples from the start. Remember the face unlock on your phone? That's a CNN, a convolutional neural network, which is a master at understanding images. The real-time translation? That's likely an RNN, a recurrent neural network, which is great with sequences. And, of course, ChatGPT? That's powered by the now famous transformer architecture, an absolute genius when it comes to understanding language and context.
And look, this isn't just some abstract, cool computer science thing. These specialized networks are out there, right now, completely reshaping our world.
The impact is, well, it's everywhere. We're talking healthcare, finance, the entertainment we consume, the cars we're starting to see on the road. Neural networks are the engine driving this massive wave of innovation.
And I mean, this isn't science fiction. This is happening today. We have networks that can spot diseases in scans, sometimes even better than a human doctor can. They stop credit card fraud in its tracks. They make our voice assistants actually useful. This tech is already woven into the fabric of our daily lives. So, here's the big takeaway. Whenever you hear those big buzzwords like AI or deep learning, what people are really talking about is the incredible power and flexibility of neural networks. They are the absolute foundation of almost all of it.
And that kind of leaves us with one last really interesting thought.
See, these systems aren't programmed with a bunch of if-then rules. They learn. They learn from the data we feed them, which means they're basically a mirror, reflecting whatever we choose to show them. And that begs a huge question. As this tech gets more and more powerful, what are we going to teach it next?